Let's take a look at this example. This time we're supposed to check if this circuit is functioning correctly. Okay, in order to do so, I'm going to first find the total resistance and total current in this circuit. And the current which I'm going to calculate, I'm going to compare with the current which is given. And after that, I'm going to see if everything is okay with it or not. So, because I have more than 2 resistors, I'm going to use the following formula. R total is equal 1 over R1 plus 1 over R2 plus 1 over R3. Okay, keep in mind we use this formula when we have more than 2 resistors. Okay, mostly because we can use also this formula for 2 resistors. Okay, but we used to use product over the sum for 2 resistors. So we have R total is equal 1 divided by, open parenthesis, 1 over 2.2k plus 1 divided by 3.3k plus 1 divided by 4.7k. So I can say R total is equal. Now we're supposed to use the calculator. So I have 1 divided by, open parenthesis, 1 divided by 2.2 exponent 3 plus 1 divided by 3.3 exponent 3 plus 1 divided by 4.7 exponent 3. Close parenthesis, this is equal 1.03 kilo ohms. So this is 1.03 kilo ohms. This is my total resistance in this circuit. Next, I'm going to find the total current. Let me write this over here. I total is equal voltage source over R total, where voltage source is equal 15 volts divided by R total 1.03 kilo ohms. And this is equal 15 divided by 1.03 exponent 3, this is equal 14.56 milliamps. Please notice that the current which I just obtained is different than the current which is in my circuit. So it means that there is something wrong with these resistors. Okay, so one of them probably shorted or open. We're supposed to verify what's wrong with them. So what I'm going to do first, of course there are many ways to do it. Let me just show you my way. I simply find the currents which goes through each resistor. Okay, so I'm going to find first I1, which is equal voltage source over R1. Keep in mind that this is the parallel circuit. In parallel circuit, all voltages are the same. So voltage source is equal to V1, is equal to V2, is equal to V3. That's why I'm going to write it simply voltage source over R1. 15 volts divided by 2.2 kilo ohms. So I have 15 divided by 2.2 exponent 3 is equal 6.81 milliamps. 6.81 milliamps. This is current which theoretically is supposed to flow into resistor R1. Next, I'm supposed to find I2. I2 is equal voltage source over R2. So this is equal 15 volts over 3.3 kilo ohms. This is equal 15 divided by 3.3 exponent 3 equals 4.54 milliamps. 4.54 milliamps. So this is my current which will flow through resistor R2. Next, I'm supposed to find current which is flowing through resistor R3. I3 is equal voltage source over R3. This is equal 15 volts over 4.7 kilo ohms. And this is equal 15 divided by 4.7 exponent 3. This is equal 3.19 milliamps. 3.19 milliamps. Okay. Now, what I used to do, I simply look at these values. Okay, and I look at the given current. Current is equal 10 milliamps. Which values, okay, which these three values, okay, added to each other will give me 10 milliamps. I have I1 and I have I3. 6.81 milliamps plus 3.19 milliamps supposed to give me 10 milliamps, right? So I can say that I13 is equal I1 plus I3. Okay, let me write this down. And my I1 is equal 6.81 milliamps plus I3, which is equal 3.19 milliamps, is equal 10 milliamps. Okay, those of you who have difficulties to use the calculator, let me show you how to do it. So this is 6.81 exponent 3 negative plus 3.19 exponent 3 negative gives me 10 milliamps. So it means that the current flows only through the resistor R1 and resistor R3. So it means also that R2 is not functioning. In other words, R2 is open. Okay, so we can say that resistance R2 is open. Okay, and if you want to make the circuit working properly, and a circuit which has to generate the current 14.56 milliamps, it means that this resistor has to be replaced by the new one. So I can say that the problem is solved.